5.1 Introducing the second law. So far we have learned about conservation of mass and the first law of thermodynamics, or conservation of energy. So any process must satisfy the conservation principles. So we formulated and applied the mass conservation and energy conservation principles for any closed systems or open systems. We are able to solve it for unknown values like work, heat transfer, or properties of a system. But these conservation principles cannot explain some thermodynamic processes. For example, we know that a hot coffee is cooled as the heat is transferred from the hot coffee to the cold surroundings. But we cannot explain why the reverse of the process cannot occur spontaneously. As the fluid in a tank is stirred by a rotating paddle wheel, the temperature of the fluid increases. If the wheel is stopped, the reverse of the process cannot occur. The thermal energy of the fluid is not expected to decrease and rotate the wheel in the opposite direction. So things only occur in a certain direction. So here's another example. Let's say 100 kilojoule of thermal energy is provided to a heat engine. So how much heat can be converted to useful work? (100 kilojoule in ideal conditions? Or is there a theoretical limit on the work output? The first law cannot determine how much heat can be converted into work. So these phenomena cannot be explained by the conservation principles alone. So to answer these questions, we need to introduce the second law of thermodynamics. So in chapter 5, we study the second law of thermodynamics and a new thermodynamic property called entropy. The second law predicts the direction of processes, establishes conditions for equilibrium, determine the best theoretical performance of cycles, engines, and other devices. The second law evaluates quantitatively the factors that preclude attainment of the best theoretical performance level. So we can compare the real devices with these theoretical limitations. And the second law develops means for evaluating properties such as internal energy and enthalpy in terms of properties that are readily obtained experimentally.